Hello everyone. In today's video, we are going to see recurrence relation in roots of polynomial for year 13 students. Let's get started. Recurrence relation. We will use the recurrence relation such as Sn is equal to alpha raised to the power n plus beta raised to the power n. We will give the values to n and we will find out the recurrence relation. If we consider the quadratic equation x square plus 5x plus 7 is equal to 0, let's suppose the roots are alpha and beta in this case. If we compare this equation with our general equation, which is ax square plus bx plus c is equal to 0, we will come to know that alpha plus beta, the sum of the roots, is basically minus b over a. If we see that value here, it will be minus 5 over 1. Let's write down here minus 5 over 1, which is equals to minus 5 here. Alpha beta is c over a. C is 7 and a is 1. So that will be 7 over 1. Let's write down here that is equals to 7. If we substitute n is equal to 1 here, we will get S1 is equal to alpha raised to the power 1 plus beta raised to the power 1, which will give me the value as sum of the roots, which is equals to minus 5. Let's write down here as alpha plus beta is minus 5, which is the same value for S1. Let's determine the value for alpha square plus beta square. In this case, I am putting n is equal to 2. S2 is equal to alpha square plus beta square. We know that alpha square plus beta square will be written as alpha square plus beta square plus 2 alpha beta minus 2 alpha beta. I can add 2 alpha beta and I can subtract 2 alpha beta. If I look at this formula, alpha square plus beta square plus 2 alpha beta, I can write down as alpha plus beta the whole square minus 2 alpha beta. If we substitute the value here, alpha plus beta square, alpha plus beta is minus 5. Let's substitute the value here. That will be equal to minus 5 the whole square minus of 2 alpha beta is equal to 7. If you solve it, that will be equal to 25 minus of 14. My answer will be equal to 11. Let's see one example here. The quadratic equation x square plus 2x minus 6 is equal to 0 has roots alpha and beta. Find the values of alpha minus beta the whole square and 1 upon alpha square plus 1 upon beta square. First, we will find out the value for alpha minus beta the whole square. Let's expand it here. Alpha minus beta the whole square will be written as alpha square plus beta square minus of 2 alpha beta. If we write down the value for alpha plus beta from the given equation here, we can find out that minus b over a is 2 over 1. Let's write down the value as minus 2 over 1, which is equals to minus 2. Alpha beta is c over a. My c value is minus 6. So minus 6 over 1, that is equals to minus 6 over 1, which is equals to minus 6. Alpha square plus beta square, as we have discussed earlier, that will be written as alpha plus beta the whole square minus of 2 alpha beta, and that is minus 2 alpha beta will be the same for this one. Alpha plus beta the whole square, the value for alpha plus beta is minus 2 the whole square minus of 4 alpha beta. Alpha beta is minus 6. Let's square it. That will be equal to 4 minus minus plus 6 4s are 24, and my answer will be equal to 28 for alpha minus beta the whole square. Let's see 1 upon alpha square plus 1 upon beta square. If we take the LCM here, you will find out that alpha square beta square will be given as beta square plus alpha square in the numerator. In the numerator, alpha square plus beta square will be written as alpha plus beta the whole square minus of 2 alpha beta over alpha beta the whole square. Let's substitute the values here. Alpha plus beta is minus 2 the whole square. Minus of 2 alpha beta is minus 6 over minus 6 the whole square. Let's solve it here. That will be equal to 4 minus minus plus 12 over 36. That is equals to 16 over 36. If I divide it with 4, that will be equal to 4, and 4 times 9 is 36. My answer will be 4 over 9. Let's see one more example here. A quadratic equation has roots alpha and beta given that 1 upon alpha plus 1 upon beta is equal to half and alpha square plus beta square is equal to 12. Find two possible quadratic equations that satisfy these values. We will first solve this equation 1 upon alpha plus 1 upon beta. Let's solve this here first. 1 upon alpha plus 1 upon beta will be written as, if you take the LCM here, alpha beta, this will be written as beta plus alpha. This is equals to 1 over 2. If you do the cross multiplication on this side, that will be equal to alpha plus beta is equal to alpha beta by 2. This is your first equation. Let's solve alpha square plus beta square. This will be written as alpha plus beta the whole square minus of 2 alpha beta. If we can substitute the value for alpha plus beta from here, alpha beta by 2, I can replace this here and I will write down as alpha beta by 2 the whole square minus of 2 alpha beta, which is equals to 12. That is given to us from this equation, which will be written as alpha square plus beta square over 4 minus of 2 alpha beta is equal to 12. If we take the LCM here, this will be written as 4 as the LCM. Alpha square beta square minus of 8 alpha beta is equal to 12. You do the cross multiplication here on this side, that will be written as alpha square beta square minus of 8 alpha beta is equal to 48. This is my second equation. I need to solve my second equation. Let's suppose that alpha beta is equal to y. If we substitute alpha beta is equal to y, let's write down the equation as y square minus of 8y is equal to 48. Move this 48 on left hand side. Y square minus of 8y minus 48 is equal to 0. I need to split the middle term. 48, I need to make the factors of that. 48, if I do the factors of that, that will be equal to 2 and that will be 24 here. Again 2 divisible, it will be 12 here. Again 2, it will be 6 here. Again 2, it will be 3 here. And again 3, it will be 1 here. If we take 3 times 2 is 6, 6 times 2 is 12. 12 minus 4 will give me 8. Let's write down here y square minus of 12y plus of 4y minus of 48 is equal to 0. Let's take y as a common factor. Y minus 12 plus 4 y minus 12 is equal to 0. The factors are y minus 12 and y plus 4 is equal to 0. The values of y for y is equal to 12 and y is equal to minus 4. If y is equal to 12, this will show you that alpha beta is equal to 12. Next is alpha beta is equal to minus 4. If we substitute alpha beta is equal to 12 in our equation number 1, we will get that alpha plus beta is equal to 12 over 2, which will give me alpha plus beta is equal to 6. If we substitute minus 4 here, we will get alpha plus beta is equal to minus 4 by 2. 2 got cancelled from here and my equation will be alpha plus beta is equal to negative 2. So these are the two values I am getting it. Here we will see that how we have to write down the quadratic equation. We know that the quadratic equation is written as x square minus of alpha plus beta x plus alpha beta is equal to 0. This is my quadratic equation. Let's substitute the first values here. X square minus of alpha beta is 6x plus alpha beta is 12 is equal to 0. My first equation is x square minus 6x plus 12 is equal to 0. This is my first equation. If I substitute here, x square minus of alpha beta is minus 2x plus alpha beta is minus 4 is equal to 0. This will be written as x square plus 2x minus 4 is equal to 0. This is my second quadratic equation. Thank you so much for watching. I hope you enjoyed my video. Don't forget to like, subscribe and leave a comment down below. Bye-bye everyone.